What's my favorite color? I'll answer what my favorite color is if you tell me what your name is. How's that, anonymous attendee? I think you already know my favorite color, though. It's blue. Seems tacky, doesn't it? But it's actually true. All right, we're about to make a start. Right, well, welcome to this webinar. Thank you all for attending, and this is going to be recorded. So if you need to pop away for a wee toilet break or something, or you want to show one of your colleagues or just go through the information again, this is a pretty high level, light. There's going to be nothing too arduous about this particular webinar. We will have training events coming up in July for Victron, and there will be 3 locations for that. The information there is available if you wanted to scan that QR code, or you can just go onto our website and have a look at what's coming up. That's on our support site, support.taspacenergy.co.nz. I can also make these slides available, in PDF form, but there's probably a lot of information that I want to cover that we're just not going to have time to cover in 1 hour. But the idea of this webinar is basically to give us a bit of a product overview, some of the new products and the main products that Taspac Energy carries, a quick look at off-grid and ESS designs, system designs, probably more around some basic real-world examples, photographs, all that sort of stuff. And then product application specifications, kind of, that's going to be mixed in with the previous 2 as well. So it probably will be worth going back through it, because I didn't quite know which to do first. Do we do the applications first, and then do we delve into products, or do we look at products and then see how they apply to applications? So yeah, if you love the sound of my voice, then you're welcome to go through this again at your leisure. So let's get into it. The main Victron product range basically covers a whole lot of different products. Victron Energy started manufacturing around about 50 years ago. I think it's coming up for their 50th anniversary very soon, unless I missed it and didn't get an invite to the party. I need to have a chat to them about that. Anyway, the inverters are the start point. They're always battery inverters. Okay, so all Victron inverters have to be attached to a battery. So you might be used to doing general grid tie solar. Then the inverters for a normal grid tie solar power system are not battery inverters. They are PV inverters normally, and some of them can have a battery attached. But Victron inverters, always a battery. So it's always start with an inverter and a battery. Now the charge controllers, Victron make a range of charge controllers, and they're always connecting the PV to the battery. So the whole Victron architecture, as far as its own products go, is what we call DC coupled. So the solar panels are coupled to the 230 volts via the DC bus, so via the battery bus. So when you put a Victron system together, you're always going to need an inverter, and almost always need a charge controller. If you've got solar, you're going to need a charge controller. There are some cases where you won't need that. We'll go through that shortly. GX devices. Now, I basically decided to call it the gateway for everything or of everything, whatever. G stands for gateway in my mind. I don't actually know why they call it GX, but so what? Doesn't matter. It goes way back. And so gateway, and X, of course, is everything. Elon Musk has changed the name of Twitter to X because he wants it to cover everything. SpaceX, he's into X, but X is pretty much everything. So a gateway is what connects everything together, and also the gateway also connects everything to the internet. So everything goes through a GX device. You can run the Victron product standalone if you want to, but it's way, way better to put a GX device in. And once you're talking a battery system, maybe $500 or $1,000 extra cost on top of that to have a GX device gives you so much more value. So I pretty much recommend every system should have one. EV chargers, they're a new kid on the block. Victron have two EV charger models, basically the same, exact same EV charger, one of them in an ugly case with a screen on it, and one of them in a nice rounded case without a screen. And initially people go, oh, I like the idea of a screen, but if you think about it, when you're plugging your car in, you're not going to plug it in and look at a screen and make sure it's charging. You just plug it in, hear the couple of beeps, and away you go. Just carry on with life. So having a system without a screen, but you've got the choice. We carry both of those models for now. There's other peripheral devices that you'll see some of them, we'll cover some of them, energy meters, bus bars, comms cables, etc. So we carry a range of those. So I want to go through the range of inverters for a start that we actually carry, because Victron have, my guess would be they might have 50 different inverter types on the market. A lot of those are not suited to the market that you're in, or maybe they are, but they're certainly not suited to the main market that Taspac Energy covers, which is residential, commercial, and industrial solar power systems. So we don't need the little 12-volt inverter that goes in a caravan. We just do not carry those. We used to carry them, but they don't move and they cause more hassle than they're worth. So we ditched those. There are other suppliers that can carry those if you desperately want them. If you want to do a special order, we can always indent any of the Victron product for you, but understand if you indent it, you can't send it back to us for a credit because it was the wrong one, or you just don't want it anymore. And there will be a limited level of tech support for indented devices. We will try our best, like we always do, but the reality is you can't know everything about everything there is to know about all the products that Victron carry. So let's have a quick look at the inverters that Victron carry. So the inverter charger basically is going to, well, let's look at your normal setup first. Normally, you've just got the grid connected to a home. Well, the Victron inverter chargers will sit between the grid and the load. So they're not like a solar inverter where they just connect into the AC mains. The Victron inverters have an AC input and they also have an AC output. They actually have two AC outputs, but we're not going to cover that in this session. But you need to connect the grid to the input of the inverter, and then it has its own internal relay to connect and disconnect the grid, and then the load is connected onto the output. And I told you this was going to be basic, but we are going to get into a bit more details later, so please don't fall asleep. I can hear your eyes glazing over already, some of you. But this really is for the basics for a lot of people who have just sort of started, dealing with Taspac or with Victron systems, or want to refresh it like some of you are in here. So thank you for that as well. It's always good to get a bit more knowledge under your belt and your brain. So the Victron inverter has to connect to a battery, right? It always has to connect to a battery. Now, you may be on grid, so that's an ESS system you're looking at there, or you may be off grid where you don't have the grid at all and you're just using a generator. So you may also decide to use both in some cases where you want a serious backup system of grid and generator. And we need to cover off some of the technicalities on that in this one, and also in the more advanced training in July. So if we look at the Multiplus 2, you're going to see the front screen pretty much looks like this, the front cover, and it's got some numbers there, right? So the model is called Multiplus 2, and then the specifics of that model you can see underneath the name there, and that is 48-3000-35. So those first two numbers, well, all three numbers are pretty important depending on how you're specifying or setting a system up. So the middle number is the power of the inverter. Now that's in VA as opposed to watts. It's a very similar figure to watts, except VA is taking into account motors, etc., and power factor. And we won't go into that. It's more technical, but effectively it's 3000 watts. It's a 3000 watt inverter. It'll do 3000 watts technically for half an hour at 25 degrees Celsius. So it is temperature dependent on how much load you're running either side of that. It will overload to a good 6000 watts for probably something like 5 to 20 seconds, again, depending on temperature. But they've got a huge surge capability, and it will overload to maybe 3 times its rated current for a split second while a motor starts. Now, the other two numbers either side of that 48 volts is the battery voltage. So that's the voltage of the battery. We only carry 48 volt inverters. Maybe we carry a couple of 24 volt models for the old off-grid market where they're still running 24 volt batteries, but most of our inverters are running at 48 volts that Taspac carries. Of course, like I said, we can get others in for you if you like. Now, 35 amps is the charging current into the battery that inverter is capable of. So that inverter can be set to charge from the AC source, like the grid or the generator. It can also charge from an AC coupled inverter that is downstream, maybe on a home or another building, such as a Gen 24 inverter. Now, bear in mind, if you're going to AC couple, you need to make sure the AC coupled inverter is below the power rating or equal to the power rating of the Victron inverter. So if you've got a Multiplus 2 48-3000, which is this one, you can only put a 3 kilowatt Gen 24 on the output of that inverter. You can't put a 10 kilowatt Gen 24 on, or this little inverter will start trying to jump off the wall and into a cold pool, or it will just end up smoking, which is bad for you. So here's a Quattro inverter. There's the front cover of a Quattro inverter. Now, Quattro inverter is a bit different, and we'll go through this shortly, but you can see the figures there, the 48, 10,000, 140. Okay, so that means it's 48 volt battery. It's 10,000 VA or 10 kilowatts, if you want to be simple about it. And it's 140 amps capable charging current back into the battery through that inverter. You can get more charging by using the DC coupled solar, which we'll cover off shortly. And that would be charging from solar panels. So if we look at the inverter range that Taspac Energy actually carry, okay? So we carry the Quattro, 48 8000, 48 10,000, 48 15,000. So they're pretty grunty. That is the largest inverter that Victron carry currently. We also carry the Multiplus 2 range. Don't worry about the 2. That just basically says that it's version 2. Victron are bringing out the Quattro version 2 shortly. I'm a little bit hesitant to bring in the brand new launched products from anyone, unless they're not that technical, right? So the reason for that is I'd rather someone else go through the pain of ironing out bugs in a brand new product. So if you see the Quattro 2s or any other Victron product, let me know if you're keen on bringing it in and using it regularly. But I wouldn't be bringing in the V1 version 1.0. So I might bring in version 1.1 or 1.2 6 months down the track. So just be patient on that. If you desperately want something, let me know, and I'll make an exception, of course. I just don't want to be loaded up with tech support issues that are just unnecessary because we're trying to jump the gun and be the first in everything. We don't have to be the first to be the best. Right. So, gee, that was tacky, wasn't it? Right. Let's look at the Multi+2 range. The Multi+2 range are grid compliant. Okay. So out of the box, you can connect the 48 3000 and the 48 5000 to the grid. You can't yet with the 8, 10, and 15. And you also cannot connect the Quattro range to the grid. They are not compliant, and the version 1 Quattro range will never be compliant with the grid. 48, 8000, 10,000, and 15,000, the Multi+2 range will eventually get grid compliance. They're just going through the hoops, as I don't know if any of you know, but it's sometimes pretty difficult to get compliance on a complex product like that. So if you're wanting to use anything that's not grid compliant, you can simply put a grid protection relay ahead of it and then rely on the grid protection relay to comply with 4777 grid requirements. So if we look at the drawings on the front there, really basic single line drawing of how each inverter works. If you look at those, you've got on the, let's look at the right hand one first. You've got one AC input on the Multi+2, and you've got two AC outputs. One of those AC outputs, the AC output 2, by default turns on when the AC input's on and turns off when the AC input drops out. And that's the same with the Quattro inverters. So if you're connected to the grid, say, you could run your big loads such as your spa pool, your water heating maybe, you know, whatever bigger loads that you don't really need running, they're kind of nice to haves, optionals, but you want them to drop out when the grid drops out, you can just wire those in on a second phase, if you like, going to the switchboard. It'll be literally the same phase, but a second cable, mains cable, going into your switchboard, running those loads, and they will drop out when the grid drops out. Simple. You can also program the AC2 output, and that could be programmed to for a variety of different reasons, which we won't get into the complexity now, but let's say it's an off-grid system. You can program that to run a hot water cylinder element when the batteries are full. So then it uses the excess solar that's available that normally would just basically turn off when the batteries get full and just tick over to run the normal loads. Well, if you put a big load on, like a 3 kilowatt element in a hot water cylinder, then that AC2 can be programmed to run that element automatically, giving them hot water from, you know, save them using more gas or whatever. Now, the Quattro inverter has two AC inputs. One can be programmed for the grid, the other can be programmed for a generator. So that's the perfect inverter if you want to have a generator backup as well as battery backup and solar for grid outages. So if you've got a customer that's really concerned about the recent disasters and, you know, storms that are coming up, or the state of the national grid or their local network, then by all means, just ask them, well, just offer them a Quattro system and say we can integrate a generator into that. You can integrate a generator into the Multi+2, but it is risky because sometimes it will be rejected, and that's a discussion for our super technical training later on. But don't specify that out of the box. Always jump to the Quattro if you want to run grid and generator. The other thing with an off-grid system is if you've got two AC inputs, you could wire one to the main generator, and you could have one as a plug that you could plug a normal 10 amp generator into if the main generator is away for servicing or simply just breaks down, because generators do break down. Oh yeah, I was just explaining that. I should have had that diagram up. There's the example of the Quattro running two AC inputs. Okay, so we can move along there. Already covered that. Okay, let's look quickly at parallel systems. You can parallel the range of inverters. Most of the inverters you can parallel from Victron. There are some that you can't. You can do them in single phase, so you could do 2 or 3 or 4 or 5 inverters onto a single phase in parallel together, just to give you a huge amount of grunt on one phase. You can split phase, so you can use this in the rural situation where you've got a two-phase installation on a say a house or something like that, and you want to back both phases up. And they can also do split phase 180 or split phase 120. So it can be, opposed or like a normal two-phase out of a three-phase system. And you can do three-phase, and you can stack multiple inverters on single phase, two-phase, or three-phase. The rule is the inverters have to be identical, so they have to have the same firmware in them. They have to have the same chipset in them. So you can't buy, say, a Multiplus 2 that was built 5 years ago, which they didn't exist then, and then try and buy a brand new one and parallel those two up. There's a risk that the chipset won't be the same and they won't work together. And there are some other rules about multi-phase systems that you need to study and know. It starts getting reasonably complex when you set a multi-phase system up. So it's not the same as a single phase setup. Just ask. I can certainly help you through what you need to know there. Okay, so if we look at what can be paralleled, the Multiplus 3000, 5000s can, the 8, 10, or 15s not yet, and it's unlikely they're saying that they will be able to be paralleled, mainly due to limitations in the electronics inside the inverter. The Quattros, yes, you can parallel those. So you can get up to 180 kVA three-phase by using multiple 15 kVA Quattros on each phase. So it's a pretty big, pretty decent system. Okay, so I don't know why I'm looking at this. So the problem with using the Quattro on the grid is that it's not grid compliant, and it never will be. So you need to drop in what's called a grid protection device. And that is basically a purpose-built PLC that controls a couple of contactors, and that gives you 4777 compliance for the whole site. Now, many of you who are doing the larger commercial jobs will be aware of these. You can use whatever one you are comfortable with. We can supply one if you want to. And they come pre-programmed pretty much. You do have to do a tiny bit of setup through the menu. But it's not too arduous. Okay, so let's look at the next one, the GX device, the gateway of everything. So a very common one that we use is called the Serbo GX. It's not Gerbo GX, which some people call it. And I call it Serbo, whatever you want to call it. You can call it, as long as we understand. Just use a product code when you order it. It's got inputs and outputs for Africa. Well, for the rest of the world as well, but there's lots of stuff going on. Okay, so you can plug batteries into it. But the first most important thing is it's got an internet connection. Okay, so the Serbo talks to the internet. And this is what you're looking at here is the VRM portal. So VRM stands for Victron Remote Monitoring. That puts all the data up online of all the devices that the Serbo is talking to. So you've got the inverters that we talked about. We're about to talk about charge controllers, energy meters, EV chargers, even Fronius inverters will talk to the Serbo GX across the local area network. So if you've connected the Fronius outside to say what the wireless Wi-Fi network, and then you come retrospectively and add in a battery backup system using the Victron, they will talk to each other over Wi-Fi. And the Serbo will talk via LAN, local area network, using RJ45 Ethernet, or it will also talk through a Wi-Fi, has its own very small built-in Wi-Fi unit, which I'm using at my place because it's right next to my Wi-Fi router. It's also you can plug in long-range Wi-Fi units. There are 3 USB ports on the Serbo GX. Serbo GX also comes with its own touchscreen, which I'm not going to show you. It's just a basic 5-inch touchscreen. There's a new GX device out, okay? And that new GX device is called the Ekrano, Ekrano. So that's another version of the GX. There are older GX devices that we pretty much don't promote anymore. The color control GX, it's got some physical buttons on it. Starting the processor in those older GX devices is pretty small and struggles with larger systems. So if you're going to have multiple devices, you don't want to buy a cheap GX or cheap out on it at all. Now, the other device that has a GX built into it is actually this little sucker. That's the Easy Solar 2 GX. Now, the Easy Solar not only has a GX in it, you can see the little screen there. I'll show you a bit more about that later. The GX also has the inverter built in and the charge, sorry, not the GX, this Easy Solar has the inverter built in and the charge controller built in. So you'll see, if we'll look at that and look at that front, it's got an inverter, charge controller, and a GX all built into it, all in one. So you can see there the spec on the inverter, and you can see the spec on the charge controller, and we'll go through what those figures mean shortly. We've already talked about the inverter. So it's got an inverter in it, it's got a charge controller, and the little symbol there, GX, that's the display screen. It's got the GX built in as well. And you get a real basic LCD display that scrolls through things like battery state of charge, what the power's doing, what the solar's doing, what the generator's doing, battery state of charge, what the power's doing, what the solar's doing, and it just keeps scrolling through. There's nothing, you can't get into in-depth menus. There's really nothing. It's just a real basic. This is a go-to kind of inverter for small systems. Like I actually used to have one of these 3 kilowatt easy solars in my own home, running the whole house. And whenever we had a grid outage, we pretty much always had too much load going on, and the thing would just overload and turn off. And I just go up to the switchboard and turn the hot water off and whatever else was required, let the thing start up again, and away we go in a power outage. So that's not really suitable. I just bought that because I wanted to test it. And there are some limitations. I think the most important limitation to consider here is this: that does not have a relay built into the Serbo GX. Now, it does have a relay, but it's run from the inverter. The relay is run from the inverter, okay? So what that means is that it's a lot more difficult to program, and there's a lot less functionality on the relay. So, and there's a lot less visibility in what state is that relay in on the VRM portal. So that is a serious limitation, especially if you're going to get an auto start generator for an off-grid scenario. Then that's the point where you would consider again breaking the breaking the Easy Solar apart into individual components and buying the individual components, inverter, charge controller, and a bigger GX device, just to get that real good functionality on the generator. You're probably looking at saving by buying the buying the Easy Solar 2 GX as opposed to the individual inverter and solar. You're probably looking at a savings of somewhere around $1,000, I think. I haven't really looked into that pricing recently. So, and Victron's pricing's come down a lot. But, you know, in the scheme of things, it could be quite nice for really budget conscious and small systems like a hunting lodge or something like that, or a little caravan, whatever. Maybe a tiny build, but tiny builds tend to have big loads attached. They cram every blooming appliance they can into it. So the inverters in the GX Solar Easy Solar 2 GXs come in 3 kilowatts and they come in 5 kilowatts, and the charge controllers respectively 70 amps, which is equivalent to 3.7 kilowatts, and 100 amps, which is equivalent to 5.3 kilowatts of solar charging. Now you can put more solar onto them than that. You can put a substantial amount more if you want to. If they're off grid, that's all good. You can over PV it. So let's now give up on the Easy Solar. We've talked enough about that. Charge controllers. So Victron, up until recently, had the 2 charge controller types on the right, that's just an example. They actually had a whole lot more than what's on the right there. And they still manufacture these charge controllers, but if we look at what the charge controller actually means as far as the numbers go, you'll see the numbers there. MPPT means it's a maximum power point tracker, which you're probably familiar with solar inverters. That's what deals with the solar. And the maximum open circuit voltage of the solar is 150 volts. The maximum charge current is 35 amps. So you see there, you've got MPPT 150, 35. And that's the model number, which is great because it's so easy just to go, oh, it's a 150, 35, cool. This is how many panels I can string out to it. Normally it's 2 or 3 panels, depending on the open circuit voltage of your panels. And this is how much current I'm going to get into the battery, 35 amps. So if you want to figure that out, you're going to go, what's 35 amps times my battery voltage equals watts. Okay, so in this case, if you got a lithium battery, you could say your battery voltage is 52. Or if I make it easy, say 50 volts, 35 amps, 50 volts, that's somewhere around 1800 watts, right? So it's about 1.8 kilowatts of solar charging capability. So you could put 2 kilowatts on there, 3 kilowatts maybe. Don't over PV them too much, but they work pretty hard, these little charge controllers. And so we carry the 70, the 150/70, the 250/70, so that you should know that, 250 volts input on the solar side, 70 amp charging. We carry the 150/100, the 250/100, and we carry the new models as well, which are the bigger one on the left there, the RS 450/100, and its big brother, the RS 450/200. So let's have a quick look at those units there. The RS 450 means you can go up to 450 volts open circuit, which you're going, oh yeah, so what? But that is actually a game changer in the design considerations of an off-grid or a hybrid grid connected ESS system. It is a game changer because what it means is you no longer have to run a cable from the solar array for every 3 panels. You can now put, say, up to 8 panels, sometimes 9, depending on the voltage of the panels. You can put 8 in series, run that down through an isolator straight into the inverter, the charge controller. And the 100 amp charge controller has 2 separate MPPT trackers. The 200 amp charge controller has 4. Okay, and considering you can get around about 3.3 kilowatts easily into each tracker, and that's just, just over a 400 watt panel times 8 is about 3.28, 3.26, 3.3 kilowatts per tracker. Easy, just a string of 8 straight down into that tracker. Done. Okay, so it also has its own little display screen, right? You can see that there. That scrolls through each tracker. So if you've got 2 trackers, it'll go solar 1, solar 2, and then it will go battery, and it will tell you what the battery's doing. Gives you a little bit of an overview of how much it's produced in the day. Quite handy if you put 2 identical arrays, one into each tracker, you can get a comparison of each of those arrays. Might be a dangerous thing for your customer, but it's actually quite good to be able to look at that either directly or even better on the VRM portal. And you can then judge if perhaps there's a problem with one of the arrays, or there might be some shading, or the panels are dirty. It's likely that both arrays will get dirty at once, but there's a fair bit about information that's handy on that. It's also got built-in earth fault monitoring that makes it compliant because it's above ELV. And it's less cost than putting in, say, an AC coupled Fronius Gen 24. Not by a huge amount, but it is less cost slightly. So, and it's a Victron centric product. And we'll also talk about what that opens up later on as far as DC coupling in the first hit when you put the first version of your system in and before your customers come back and want more panels. So let's look at some applications. The system on the left was, I think, installed around about 4 years ago from memory. And you'll see there it's got a DC charge controller, a smaller one, and it's also got a Fronius Primo inverter, and that was the go-to. The Fronius would normally take the bulk of the panels, and the DC charger was used for what we call black start. You definitely need some DC in a system so that if the power goes off or the battery goes really flat and the inverter turns off, the next day that DC coupled solar that you can see there, that DC coupled solar is responsible for charging the battery back up, even though the system is dead. And then when the inverter sees that the battery voltage is all good, it's like, yep, I'm happy, it will start up. And then that will liven up the AC coupled solar, which was previously dead because it had no power, obviously, because the inverter was off. And the AC coupled solar, and the whole system is now back up and running as per normal. So sometimes a system like this would take 3 or 4 hours of good sunlight with a small DC charge controller to recuperate. But now on the right-hand side, you see here, this is a system installed maybe a year ago with an RS450-200. You can tell that because you got 4 inputs in there. And that's all DC. So we've got, I think that's got just over 10 kilowatts of PV on there. A 10 kilowatt Quattro, you can see the word Quattro there, and a couple of batteries and the bus bars. So we can look at those bus bars now. This is what you're facing. If you don't use bus bars, you have to make your own. If you do use the Victron bus bars, it's really tidy. You can basically bring all the cables in to the bus bar and hide them in trunking, which is really nice. And the bus bars clip on next to each other, as you can see there. So let's look at some design examples, okay? So this system here is an off-grid system. It could well be an ESS system, but being a Quattro, you would need to have an amount of, well, you'd need to have a grid protection relay, sorry. And if we look at that system, then this is how it is sort of electrically wired. Just a basic schematic. I can draw these up for you, but I'll only do it after you've got the job over the line, and I just don't have the time to do these for every single job that you do. Often you don't need something this complex, but it is handy for a technician to be able to follow through a diagram like this first time through. It's not an as-built diagram. It's certainly not a certified design. It is still your responsibility to use the correct cable sizing, make sure everything's safe. There's obvious things that are not included in this diagram. One you'll be able to notice is no earth on the array. So it's not something like, this is not a certified design. It's not an it's not an architectural engineering drawing. It's just a basic single line diagram. So you can get your head around, oh, that's how it goes together. And these are the kind of, balance of system components that we might need. But get in touch with me if you're doing a first couple of systems, and I can certainly help out with that. Or if you're doing something that's a lot more complex than you're used to, then we can thrash this out in a diagram, and it really does help you to understand it. And also, believe it or not, a lot of guys put these diagrams in front of their end customers. It's pretty much clear enough to follow through, and it's not too technical for them to just get lost. Okay, so that is that system there, and we'll go through that shortly. Okay, actually, we'll go through it right now. When we're designing an off-grid system, the number one most important thing you must do is get a handle on their loads. You do not want, like, this is my go-to kind of quote. If people don't want to give me a load list, then I just use the analogy. If you go to a car yard and say, I want a car, to the sales guy, go, I want a car to tow the boat, and they give you this, and they don't ask you what the boat is, they make the assumption it might just be a tin dinghy. It's the same as trying to design an off-grid solar power system or any solar power system without understanding the underlying load, but especially off-grid. If you do this, yes, that will tow the boat, but probably won't get it out of the water up the boat ramp. So just will not handle it, and it'll end up the customer will be very upset. So if the customer's going, oh no, we just got a few appliances, or we've got 10 plugs, can you do that? Can you do a shed? You've got to find out what the loads are, and you've got to confirm with them in writing what they agree they are going to load up on the system. Now they can change it if they like. They can upgrade their boat to something like this. You know, they can put on a spa pool if they want to, but in writing at the start of the job, you've got it written down with the customer, so that if there's any argument, you say, well, we discussed this load. As your engineer, I designed your system for that load, and now you've come along and you've added this load, and that's fine by me. I'm perfectly happy. I'm not blaming you. You can have a spa if you want to, but it's going to cost you another 20 grand in equipment, or it's going to cost you a whole lot of diesel in your generator. So your power requirements, I used to map them out like that. I would get an Excel spreadsheet and just write down the loads myself after they'd given them to me on the phone. I'd use that and send them this back. And so this gives you a proportion of how much load each appliance uses. And it's a bit of an eye-opener. I think this particular load is the peak load sheet, but you can do the same with kilowatt hours per day. You're after kilowatt hours per day is your most important metric that you're looking for. So here's my first rule of thumb. I haven't shared this with many people because there's some calculators out there, and you've probably seen them, spreadsheets, whatever, that are so flippant complex. It's unbelievable. It would take you a day to go through the thing, your customer a day, and they give up. And they just say, oh, I give up on this. I'm not going to fill this out. And they end up going online and buying something from Grid Free and regretting it, you know. So it's like, I just go through them on the phone and I go, have you got a fridge? Yep. Fridge, freezer. Yep. Cool. You got a deep freeze? Yep. You got a washing machine and a dishwasher? Yes, we do. Great. What else have you got? Oh, nothing. Oh, okay. Have you got a water pump? Oh, yeah. We've got a water pump. People forget about that. Will you have a septic tank? Off-grid systems often will have a septic tank. And sometimes the septic tank is powered. Most often it is. Sometimes it's just a gravity feed one and you don't need to worry about it. But you run through the major loads. Forget about LED lights. Forget about laptops charging, even TVs, unless it's like a 120-inch blooming plasma super duper thing and they watch it all night long. They'll let you know about that. Or they're major gamers or something like that, or they've got a computer that's doing Bitcoin mining. All those sorts of things need to be taken into account. But a normal household, right? We're just talking a normal household, and we're not talking about space heating or water heating. Those two need to be put aside for now. And if they say, oh, we want heating, we want to heat the house with a heat pump and we want to do hot water, well, you just basically say to them, look, a normal household power bill is split into three things. Normally it's a third hot water cost and a third space heating in the winter. And the other third is everything else. All these other appliances that we've got up here is the other third. So if you want to bring in hot water, for instance, your load daily is going to go from 6 kilowatt hours or 9 kilowatt hours a day up to probably 20 kilowatt hours a day. And so your system is going to double in price just by adding hot water. Now, it doesn't mean you can't add hot water. There are strategic ways around that. which we will cover in more in depth because we're running out of time at the moment. But same with space heating. Doesn't mean you can't do it. You can run anything you want to off the grid. They're running mines in Australia off the grid. They're running whole countries off grid. You can run whatever you want, but your pockets have to be deep enough if you want to live a decent, reasonable life. You know, you don't want power cuts at 2 a.m. every single morning and then have to replace your battery because you've hammered the heck out of a system that's half the size you need it to be. I'll just drop this in here. I haven't written this down, but you might want to write it down. For hot water heating, the average person in an average home will require it's actually the average that I've seen out of the 600 hot water cylinders I've got monitored, 3.1 kilowatt hours per day per person in the home. And the way to remember that, if you want, remember it's pi, pi r squared. It's pi, 3.1415, whatever it is, 972. So pi is 3.1. Okay, so it's 3.1 kilowatt hours, raw kilowatt hours. So if you're using a heat pump for hot water, great. That reduces it down by maybe a third. So now you're down to maybe 400 watt hours. Oh, sorry, 1 kilowatt hour rather than 3 for a heat pump system. So if you've got 2 people in the home, then you're going to be looking at 6 kilowatt hours a day of heating, okay, for hot water usage. Now, if they're really frugal or they're willing to miss out showers and are dirty hippies, that's fine. Used to have a few of those, but normal off-grid systems now are not dirty hippies. They are normally corporates that have bought their dream section and realize it's going to cost 100, 200 grand to get a cable there. So, right, let's move on. That's the rule of thumb on load. So actually, let me just quickly cover that off. If you put 1.5 kilowatt hours a day for each of those major appliances in the back of your mind, that's pretty close. Okay, so I've got a deep freeze that's upright. It says it uses 365 kilowatt hours a day, which equals 1 kilowatt hour. A year, which equals 1 kilowatt hour a day. Great. I turned it on. It uses 1.5 on the lowest setting. A dishwasher depends how often you use it, obviously, but average out about 1.5. A washing machine actually uses less, quite a bit less. But if they're going to use a warm wash, you've got to allow for 1.5. And all these appliances actually use a reasonable amount less than 1.5 kilowatt hours a day. In reality, some use more. My freezer uses about 2. So it swings and roundabouts. But if you can add up, I've got 1, 2, 3, 4, 5, 6 appliances at 1.5 kilowatt hours a day. That is 9 kilowatt hours a day. Now, if we're going to be frugal, we could say it's 1 kilowatt hour a day per appliance. So you're now designing a system that is between 6 and 9 kilowatt hours a day. So how do you do that? Quick rule of thumb. My rule of thumb is 1, 3, and 5, and I'm going to change that shortly. But for now, it's 1, 3, 5. Pretty easy to stick to. Load, kilowatt hours per day times 1 is kilowatts of PV. Load, kilowatt hours a day times 3 is kilowatt hours of lithium that you should install. And that will give you 5 kilowatt hours a day of autonomy if the load is accurate. So 5 kilowatt hours a day, 5 days of autonomy basically means 5 days of running at that load with these. If you end up selling and installing this size system, they won't need the generator for 5 days in bad weather. That's a very, very decent system. It's almost generator less. And some customers that I've got that have actually stuck to this rule and are using the amount of load that we estimated, usually you're plus or minus 20%. But some customers I've got, the only time their generator runs is once a month on a test run. They have gone through, like even the storms that we had recently, gone through those storms and never needed the generator. The only reason they started it was just to make sure it was running. Okay, so that's a good design. You can cut that back, but it's a great place to start, because if you cut back and try and make a small system, and you're going, oh, I know this is going to struggle in the winter, in the back of your mind, you're not being their engineer, you're being their accountant. And it's not your job. Your job as their engineer. Even if they give you a budget, say, look, I'm going to give you a system that I know is going to work really well. And then we can talk about cutting it back to suit your budget. Okay. And there's really simple ways to do that. Now, the quick rule of thumb for pricing. Now, the reason I'm giving you these rules of thumb is you can, in a single conversation, in a single conversation on the phone, after about 10 minutes of discussion about their appliances, I'm writing them down on my pad. I can spit out an installed figure, including GST, on the phone to them, estimated for a really top end system, knowing that you're using Victron equipment, Freedom One batteries, REC panels, everything except the generator, including installation. And that gives you enough margin to run a decent company, to give you backup support. You can go back to the customer later on and with a smile on your face and give them support 2 or 3 times whenever they call you and want to talk through the system again because I forgot how to start the generator. You can give them all that support, and you can give them warranty support, labor, and all that's required for that sort of stuff. And you can also, out of this rule of thumb, you can also pay a salesperson a commission. Okay, so you could do it for less if you want to, but what I often did in the end days of my business, when it wasn't, cheap hippies, it was actually really decent customers, I would stick to this rule of thumb. I'd say if it's a 6 kilowatt hour a day system, it's going to cost you around about, I would say, 55 to 60 grand, something like that, just depending on complexities and what comes out when we go through it in detail. And they'd go, oh, okay, yeah, cool. And then they'd start asking questions, and immediately you've qualified the customer in 10 minutes. You haven't gone through and done a full design, individual itemized quote. You haven't done any of that. You've just qualified them, and you know that there's enough in it for you to pretty much cover anything. You can, in this price, you can cover trenching, as long as it's not more than, say, 20 meters. I've done systems where I didn't know I had to trench to the house, and I'd forgotten about that, and the Sparky thought it was me doing it. I thought it was the Sparky, and I just said to the customer, don't worry about it. I'll come back tomorrow with a trencher. And I put the cable in, and I've got enough margin in the job at that rule of thumb to do that. Now, you'll be thinking, oh, but we've got to compete with people. In the off-grid market, you don't compete a heck of a lot. You don't come up against competing quotes. And when you do, you will have a 5-day system against their 2-day system. And your customer should be educated enough by then to know that, boy, they're going to run the generator a lot if they go for that cheap system. And then you can always cut back a battery on your system if you want to. So this is real world performance of a system that I have installed a few years ago now, and I'm just going to figure out how I can push play on this thing. There you go. This is the VRM portal. You can go through day to day. This was a 9 kilowatt hour a day estimated load, and you can see there sometimes we're getting up around 12 kilowatt hours a day. And now look at the solar in a bad day, couple of bad days. We've got very little solar gain there. The generator was minuscule. That was an auto start. Happened to happen, 1 kilowatt hour a day given. And then after 3 days, boom, the sun comes out and we're back up to 100% and carrying on. Okay. So a well-designed system will span 3 or 4 or 5 days. You can see that the battery only really got down to something like 40%, 50%, something like that. And you always get a bit of recuperation from a decent sized solar array. So that's that. Let's look at, this is the same system we were talking about. That's the array there, and that's the build, the inverter and charge controller and batteries. Pretty simple, straightforward. And that's their dashboard. So you can see the dashboard there with basic display of what they get. There are also way more advanced displays on the dashboard, but that is pretty much their system at 100% ticking over, no problem. Okay, so let's look at a different use case, is diesel generator offset. I'm going to run through this really quick. If you chuck a battery and inverter only between a diesel generator and its load, you can decrease the diesel consumption a huge amount and increase the generator efficiency. So when it is running, it's running at a higher load, and it's running at the more efficient load of about 80% duty. It reduces the servicing cost something radical, because instead of running 24/7, if you design the system right, you might only be running for 5 hours a day rather than 24 hours a day, or even less. That means you've got reduced noise, and you can sometimes, if you design the battery big enough, you can span, and then of course you can span the nighttime period. Then of course you've got reduced emissions. Okay, and everyone's all about offsetting carbon, right? So if you've got customers that are running diesel generators full noise, then this is the solution for them, especially if it's a permanent installation running, whatever. And you'd be surprised, there's quite a few of them around. There's the sizing consideration for diesel. I'm not going to get into that. You've got it there. You can look back on the thing. I don't want to go through that step by step. But those are the main rules that you want to look at for sizing a diesel offset system. And here's one a bit of a case study that a customer of ours installed a couple of years ago. It's on Great Mercury Island. That was the end user. And the generator requirement was reduced to 16% from 100%. They gave us the wrong daily consumption initially. It was using grow watts, and they couldn't handle the generator. And the grow watts were reporting 36 kilowatt hours per day. And when we put our system in and turned it on, it was using 80 kilowatt hours a day. So it's working really, really hard, but it's working well. That's it there. Got a decent solar array. Solar helps offset the diesel as well, obviously, but you don't necessarily need it. And there's the 3-phase setup. It's running 5 houses on the island, and a kitchen and a workshop, and it's just ticking over quite nicely. So you can do a big system, or you can do small systems with diesel offset. Again, the sizing rules are on the page, a couple of pages beforehand. And there's the results. You can see there 19% offset in the last, 19% diesel consumption or generator usage, top right there on the last 7 days. 22% the last 24 hours, so they might have had some bad weather or a higher load. They're actually running at more than 80 kilowatt hours a day. They're now running about 95. That's always going to happen. You're going to get creep in the load. The last 30 days, 14%. The last 365 days, they're down to 13% diesel generator usage as opposed to 100%. Customers are absolutely wrapped. I presented this data in front of their accountants. We went back to the island about 6 months later, presented it to their accountants, and the guy literally jumped out of his seat and stared about 2 feet away from the screen and said, "Is that 16%?" I'm like, "Yep." Wow. He was just so wrapped, and that's basically sold the next system for our customer. So, right. Another quick one was a surgery clinic in Tauranga, and I'm not going to say who it was, but you'll be able to figure it out later on. Customer, the installer, so the requirements that they came, we have to be able to operate, literally operate, because it's a surgery. We have to be able to operate all day during a grid outage, and we can't have any outage. So it's got to be a quick changeover. We've got to have a clear indication, really visible and clear, of the time left in the battery, just the battery. So we know that if there's a storm, we can flick the batteries over to keep them charged. They've got a keep charge battery switch that they can flick. If there's a storm and they're operating, they can flick it on to keep batteries charged, and they know that they've got 2 hours or 3 hours left in the battery if the sun's not shining. We want full building backup, but they also wanted to automate the aircon to turn off at below a certain battery level. And we want the alert that if the grid goes down, because they've got really fast changeover, they don't actually notice that the grid goes down. The lights don't even flick. And so they can be just pottering away and the aircon's still running full noise. They don't even know. So they wanted an alert. And that turned out being a flashing light in a hallway and a buzzer with a mute button on it. So the buzzer just goes when the grid goes down. Easy. All that can be done with the Victron system. And they had no room. So they built an outdoor cupboard and it was really small. And that is the result, crammed in there, a really, really tidy, compact install. Okay, so that's a 45 kVA three-phase system, 40 kilowatt hours of storage. You can see those other specs, AC coupled and DC coupled. The main reason is that the AC coupled gives you really high efficiency solar because you've only got one point of conversion. We'll go through that in more. But look at this custom dashboard. I want to show you this. This is the dashboard that our installers built using Node-RED. That's a built-in addition to the Victron software. You don't need to buy any special dashboarding. They've just got a screen up in the clinic showing this, and you can see there battery time remaining 2 hours 57 minutes in this snapshot. State of charge, solar generation, power usage, really, really good. And that was built using Node-RED, which looks like this. That's part of that dashboarding. And it's a drag and drop automation system. You do have to be a bit savvy. A lot of Node-RED stuff is beyond me. I'm not a software developer, but I have about 3 contacts that I can call on if you want to get Node-RED working for a customized solution and doing some of this cool dashboarding or even integrating certain things or automating stuff on the site, whatever you want to do. We can play around with Node-RED. I've got a few flows that I've built myself, and we're nearly done, by the way. I realize it's 5 o'clock, so we'll be out shortly. But yeah, I've also got a contact in New Zealand that is willing to do Node-RED under contract for us or for you. And we can easily get a estimate or a quote sorted for that. It's not super expensive in the scheme of things. You might put aside, I don't know, let's say you put aside $1,000 or a couple of grand. That will get you a pretty swish setup. And then yeah, and there's also a company, if you're not really keen, if it's sort of a bit too close to home to get a Kiwi person to program it for you, I have contacts through the Victron installer network in Australia who do one company there that does pretty much Node-RED all the time, and they are willing to build whatever flows we need. So that's going to become really, really important in the future when we get more of these grid connected plans that are responding, wanting to respond to the spot price perhaps for export. So you can use your battery now to earn more money when the spot price goes up and the grid wants it. Yeah, so that all that sort of stuff is coming. So that was a pretty cool setup. Here's an design considerations. Just very quickly, try and start with DC coupled solar. Don't put a Fronius in straight away. I've got nothing against Fronius, but you've got a 1-for-1 rule in the Victron. You can't put, like I said, you can't put a 10 kilowatt Gen 24 AC coupled inverter onto a 5 kilowatt multiplus, or you'll cook it, and you certainly won't get warranty on that. So if you have to put that in, there are ways around that, but basically what you want to do is start with DC coupled in the main building, bring the panels in, and then you can put AC coupled in later on a different building without having to trench DC cables through. If you put AC coupled in straight away, you have no headroom left to put AC coupled in and expand on another building later on. Okay, so that's the main reason. Ensure that your site has good internet, or consider pre-building the system at the workshop. Here's one I prepared earlier. One of our customers prepared earlier. Pre-built, right? So they have just pre-wired this, and then we programmed it all up, and everyone's happy, and away we go. So consider doing that. It also means if it's your first couple, or it doesn't matter if it's your first couple, but what it also means is that you are working at your leisure and at your pace. You haven't got the customer hanging over your head asking questions, annoying you, and you've pretty much got all the tools on site that you can just make a really, really nice, tidy job of. Disconnect the batteries later on, maybe unhang the inverter, but just get the guys to carry the thing onto a trailer or into your truck or whatever. Take it on site, screw it to the wall, connect it up, commission it, walk away. And I can help you with pre-programming it as well, things like that, but I can help with lots. Discuss with the Taspac team what you want to do. Ahead of time is always good. Like I said, I can help with diagrams. We can pre-build. We can help with really complex setups. And there's a really beautiful one from some friends of ours in the deep south. So all I would say is a bit of a challenge to you. Don't say no. Say, I think we can do that. And then walk away with no look of panic at all on your face. As soon as you get out of earshot, give me a call. And we can help set things up for you. So here's this one here was installed by a really great company that we deal with, and it was their first multi-inverter system. They'd done a lot of single inverter systems. This was the first multi-inverter system. They did a lot of research, a lot of talking with us. They're really quite concerned about it, but now they've done this system, they can just walk into any inverter, multi-inverter setup, that any sale, and go, yes, we can do that, because they know what they're doing and they've done it. And I went to site on this particular one and helped them commission it. And we spent quite a bit of time, holding the hand and answering questions. And so that's what I love to do, is help you get out of the market that you feel you might be just like mundane or competitive, or no real kind of money you're making in this market, and get into this sort of stuff where you can back up a whole factory or a whole building, add some real value, and really start expanding your business upwards. So thank you very much. And I will now take, let's do 5 minutes of questions. If you've got any questions, please let me know. Take a photo of that, snap that future training QR code thingy, and have an absolute lovely day. If you've got any questions, I'm going to wait, because sometimes it takes a while for you to type them. Just let me know. And otherwise, thank you all very much for attending. Really appreciate your time.